Hello there. In this video we're going to discuss how to solve linear equations of a variety of different difficulties. First off, let us define what a linear equation is. So an equation is said to be linear provided that it can be written in the form ax plus b is equal to 0 with a not being equal to 0. In this case, its solution is x is equal to negative b over a. So we're going to investigate how to solve a variety of these types of equations, and that will be pretty much the focus of this video. So to begin, let us talk about a couple equations that are not linear that some people may think are but actually are not. So example 1, consider the equation 3x plus 5 is equal to 3x minus 8. So if I try and isolate the variables, say x on one side and the numbers on the other, then on the left hand side I'm going to get 0x is equal to, so that's going to be minus 13, which is the same thing as writing the equation 0x plus 13 is equal to 0. So by the definition of a linear equation, it's one that can be written in the form ax plus b is equal to 0, where a is a non-zero constant. So if the constant in front of the x term, once you combine and simplify, is equal to 0, then this is not a linear equation. Similarly, if you have the equation 5x plus 2 is equal to 5x plus 2, you can verify yourself that this is the same thing as writing 0x plus 0 is equal to 0. Again, the coefficient in front of x is going to be 0, so this equation right here is also not a linear equation. Some people usually define a linear equation because the highest exponent in the equation is equal to 1, but that's actually not exactly true, at least not always. So let's look at a couple equations and how to solve them when the equation is actually linear. So the first example that we're going to solve is the equation 3x minus 5 is equal to 7. So this is a very basic equation because there's only one x term, namely 3x, and the rest are constants. So we're going to begin by isolating our constant terms. So let's begin by moving our 5 to the right hand side. So we get that 3x must be equal to 12. Now 3 times some unknown number must be equal to 12. You should be able to guess that, but let's algebraically solve that. So let's divide both sides of this equation by 3. So from here we get that x is equal to 12 divided by 3, which is equal to 4. So you can verify this solution actually works by substituting in the original equation, and you get that 3 times 4 minus 5, which is the same as 12 minus 5, which is 7, equals the right-hand side of this equation. So let's make this equation a little bit more complex. Let's consider 3 times 2x minus 3 plus 1 is equal to 4. When you have linear equations that have parentheses, I suggest distributing across all the parentheses first, and then combining like terms afterwards. So 3 times 2x is going to be equal to 6x. 3 times negative 3 is going to be negative 9. We have plus 1, and then that's going to be equal to 4. Now I'm going to combine like terms on the left-hand side. So we get 6x, so negative 9 plus 1 is going to be negative 8, and that's going to be equal to 4. And this puts it in the same exact form that the first example was in. So I'm going to begin by adding 8 to both sides. So I get that 6x must be equal to 12. So this is very easy to solve as well. So I'm going to divide both sides by 6. So I get that x must be equal to 12 divided by 6, which is of course equal to 2. you can substitute 2 into the original equation and verify that the left-hand side is actually equal to 4. So let's make it a little bit more complex. So let's do negative 2 times 3x minus 1 plus 2 times x plus 1 is equal to 2x. So now I have variable terms on both the left and the right hand side. So I'm going to begin by the same exact strategy as before. I'm going to distribute across my parentheses. So negative 2 is going to be distributed, and positive 2 will be distributed across that parenthesis as well. So this is going to give us negative 6x plus 2 plus 2x plus 2 must be equal to 2x. I'll now combine like terms on the left hand side. So I'm going to combine my x terms and I'm going to combine my constant terms. So this is going to give me, so negative 6x plus 2x is going to give us negative 4x. 2 plus 2 is going to give us 4. And on the right hand side we still have 2x. So now I'm going to bring my x terms to one side. So I'm going to subtract 2x from both sides. So this is going to give me negative 6x plus 4 is going to be equal to 0. Then I'm going to move my 4 to the right hand side. So that's going to give me negative 6x is going to be equal to negative 4. And now I'm going to solve for x finally and divide both sides by negative 6. So I get that x must be equal to negative 4 over negative 6, which is the same as positive 2/3. And you can subtract this into the original equation to verify that it is true. Now let's make the equations a little bit more complex on both sides of the equation. So example 4. Suppose we have negative 3 multiplied by the quantity 2 minus x minus 2 times the quantity x minus 4 is equal to 7 times the quantity x minus 1 plus 3. So I'm going to begin by distributing across the parentheses. So negative 3 is going to be multiplied by 2 minus x, negative 2 is going to be multiplied by x minus 4, and 7 is going to be multiplied by x minus 1. So that's going to give me negative 3 times 2 is going to give us negative 6. Negative 3 times negative x is going to be positive 3x. Negative 2 times x is going to give us negative 2x. Negative 2 times negative 4 is going to give us positive 8. 7 times x is 7x. And 7 times negative 1 is negative 7 with a plus 3 at the end. Now I'm going to combine like terms everywhere I can. So I have an x term there, an x term there, a constant term there, a constant term there, and I have a constant term on the right as well that I can combine. So once I do that, I'm going to get what? So 3x minus 2x is going to give us positive x. Negative 6 plus 8 is going to give us positive 2. And on the right hand side I have 7x, and negative 7 plus 3 is going to be minus 4. So now I'm going to subtract 7x from both sides. Or you can subtract x from both sides, you'll get the same exact answer. And I'll also subtract 2 from both sides as well. So x minus 7x is going to be minus 6x. On the right hand side I get negative 4 minus 2, which is also negative 6. So now I'm going to finish this and divide both sides by negative 6. So finally I get that x must be equal to negative 6 over negative 6, which is positive 1. As a last example, let us consider an example where there are fractions in the problem. So say 1/2 times x minus 1 plus 3/4 is equal to negative 5/6 times x minus 2 plus 1. So the first thing I'm going to do is find the least common multiple of 2, 4, and 6. So the least common multiple of 2, 4, and 6, one can easily find that to be equal to 12. So I'm going to multiply both sides of this equation by 12. Doing so is going to eliminate all of my fractions. So to do this, you need to identify where the terms are. So I have 1/2 of x minus 1 as a term, 3/4 as a term, negative 5/6 of x minus 2 as a term, and 1 as a term. So I'm going to distribute 12 to the first term, the second term, and then 12 times the first term and the second term. So once I do that, I'm going to have 12 times 1/2, which is going to be 6 times x minus 1. 12 times 3/4 is the same as 12 divided by 4, which is 3, and 3 times 3 is 9. So this is the same as 12 times 3/4. This is the same as 12 times 1/2. And this is going to be equal to, so 12 times negative 5 is 6, so 12 divided by 6 is 2, and 2 times 5 is 10. So I have negative 10, so this is 12 times negative 5/6 times x minus 2, and then 12 times 1 is going to be 12. So this is some fraction simplification. So from here I'm going to distribute across my parentheses whenever I can. So this is going to give me 6x minus 6 plus 9 is equal to negative 10x plus 20 plus 12. I'm now going to combine like terms, negative 6 and 9, 20 and 12. So this is going to give me 6x plus 3 is equal to negative 10x plus 32. Now I'm going to isolate my constants, so subtract 3 from both sides, and I'm going to add 10x to both sides to get my x's on one side as well. So this is going to give us 16x is going to be equal to 32 minus 3 is going to be 29. And then from here I can finish the problem by dividing both sides by 16. So I get that the final solution is 29/16 as an improper fraction. And these are just some strategies that you can use in order to solve linear equations.